Hello everyone, thanks for stopping in. Today we're going to be talking about Math 120, section 10.3, and this section deals with compound interest. So compound interest is interest that is calculated for the principal and any previously accumulated interest. It's interest that is calculated for the principal and any previously accumulated interest. So the compound part is telling you it's basically interest on the interest, right? Now, we can look at the formula. The formula is a little crazy. The formula is A equals P parentheses 1 plus R over N to the N times T. Here, P, R, and T we already know. Principal, rate, and time. We need to define what A and N are, right? We already know R, P, and T, right? We already have seen those in our regular interest formula. So we need to calculate these other numbers. A is the total account value. When you're calculating compound interest, you don't just calculate the interest, you actually calculate the total amount that's in the account, including the principal, right? Normally when we calculate interest, we calculate the interest and then add it to the principal, and that gives you the total amount. In the compound interest formula, the total amount is already taken into measure. So if you take out a $3,000 savings account, the amount here, once you calculate the interest, will be $3,000 plus the interest. It'll calculate the interest for you. N is the number of compounds per year. The number of compounds per year. And that'll make sense once we see our first example. So let's look at how an example of this will look. Catherine invested $3,000 in a savings account with an interest rate of 1.8%, compounded monthly. Well, the principal is $3,000. The rate is 0.018, right? 1.8% as a decimal. The time is, it says here, 2 years, right? If Catherine makes no other deposits, can determine the amount in the savings account after 2 years. And the number of compounds per year, if it's compounded monthly, that would be 12 compounds for the year. So A is equal to the principal is 3,000, parentheses, 1 plus R is 0.018, divided by N, which is 12, all raised to the 12 times 2 power. Now, this formula gets a little bit messy, and if you don't have a scientific calculator, you can't work it out on a calculator like this. This doesn't have a nice way to work it out. However, we could type the value into Google by typing 3,000 parentheses 1 plus 0.018, and then we would type the slash symbol 12, close parentheses, caret sign, open parentheses, 12 times 2, close parentheses. If you type this into Google exactly as it's written, it will give you the actual answer. It will calculate the answer for you if you type it in like that. Now, if I type that into Google, I get A is equal to $3,109.88. So after 2 years, Catherine has earned $109.88 on her $3,000 investment, right? That's what the total account value is telling me, right? She invested $3,000 and now has $3,100. So she's made about $100 in interest, right? That's how savings accounts work, right? You earn money over time. Now, we can type this into Google, or if you have a scientific calculator, you can use that as well. Both will give you the value. Now, let's look at our second example. Calculate the interest on $3,000 at 4%, compounded biannually for 7 years. Well, the principal, once again, I'm investing $3,000. The rate is 0.044%, right? The time is 7 years, and biannually tells me I compound twice per year, right? Bi means 2. Well, to set up my formula, A equals, I plug in 3,000, parentheses, 1 plus 0.04 over 2, n is 2. 2, n times t is 2 times 7. Which I could type into Google, just like above, by typing 3,000 times 1 plus 0.04 divided by 2, parentheses, caret symbol, parentheses, 2 times 7. The times key can be the asterisk on your keyboard, right? The asterisk is the times key, or if you're using the Google calculator, you can type the multiplication symbol. You could type this in. If you do, you find that A is going to be equal to, well, let's type it in. You can't see me typing, but I'm typing 3,000, parentheses, 1 plus 0.04 over 2, close parentheses, 2, the 2 times 7, which gives me a value of $3,958.44. And there should be a dollar sign there, right? It's money. Same thing up here. Dollar signs, right? We're calculating money. Now, that's how much is in the account. So how much interest was there? Well, to calculate the interest, I would take away the 3,000, right? The interest would be equal to 958.44, right? The total amount is 3,958.44, and the principal is 3,000. So the difference would be how much interest has accrued. Now, we can also calculate what's called an effective annual yield. That is the simple interest rate. So the effective annual yield is the simple interest rate that is equivalent to the compound rate, the compound interest rate, over the same time period. So we can calculate the simple interest rate that's equivalent to the compound interest rate over the same period of time. And let's determine some APYs. To determine them, we're going to use the same formula. A equals P times 1 plus R over N, N times T. But we're going to be a little bit clever. For this, we're going to use A equals, for our principal, we're just going to use $1. We're just going to figure out what happens to, we're going to use $100. Because $100 will be in terms of a percentage, right? Percentages are always in terms of 100. We're going to break our principal down into the base case of 100. Now, I want to do 2% compounded quarterly. The formula is 1 plus the rate, 0.02, over quarterly would be 4 compounds, and how many periods is that for 1 year? Well, that'd be 4 periods for the 1 year, right? 4 periods times 1 year. We're looking at the annual percentage yield. So in a single year, how much interest is accrued? Notice we were a little clever. We worked the problem the same way, R, N, N, and T, but we manipulated T to be 1 year, because it's the annual percentage yield, right? It's a single year. And we manipulated the principal to be in terms of 100, because we want a percentage. Well, using the same trick as before with my calculator, I find out that the APY, this gives me 102.01505. So from $100, I have now made $2.01505 extra dollars. That can be my percentage. My APY is equal to the difference between these two numbers, 2.01505%. That's the difference between 100 and 102.01505, right? This is my APY. That's why we use the number 100, because it allows us to quickly find our answer. How about 3% compounded monthly? Well, we're going to do the same thing, but with a few slight changes. We'll still use the same trick. We're going to use $100, because percentages are always in terms of 100. We're going to have a parentheses. We'll do 1 plus the rate is now 3% divided by the number of compounds. If it's monthly, that's 12 for the year, which means I have 12 times 1 for my exponent, right? Well, once again, typing into Google will give me a value. When I type this into Google, I get 103.041596. So my APY would be, once again, it's the difference between 100 and the answer. It'd be 3.041596%. Notice each percentage was a smidgen higher than the original, right? Compounding interest is always going to be greater than simple interest. The APY is the simple interest rate that returns the same amount of money for the same time period, 1 year, right? The APY, the annual percentage yield. That we can calculate. We can calculate it. Now, we have one last formula to look at. So we've used this formula, A equals P, parentheses 1 plus R over N, parentheses to the N times T. And we saw how we can use Google to type the answers in to calculate them, right? We all have Google. What about a present value formula? What if you want to make an investment? Well, the present value formula is all of the same letters. We're just going to rearrange it to be the amount. So we're calculating how much principal you need to invest to get a certain amount. And to do that, we put 1 plus R over N to the N times T. Notice we're just rearranging this same formula. It's a little messy, but we use this when we want to know how much to invest to have a specific amount in the future. And the best way to think about this would be with an example. So let's say William would like his daughter to attend college in 6 years. So maybe his daughter is a 12-year-old high school student, right? Or middle school, or whatever age she would be. But she's going to be attending college in 6 years. He would like to invest enough money in a CD, a certificate of deposit, now to pay for his daughter's college expenses. So he's trying to invest money now, so 6 years later he can pay for his daughter's college. He estimates he'll need $30,000 in 6 years. How much should he invest now in a CD that has a 2.5% interest compounded quarterly? So let's see what we have. The time frame is 6 years. The rate is 0.025, right? 2.5% as a decimal. The amount he would like is 30,000. And the number of compounds quarterly would be 4 compounds per year, right? There's 4 quarters in a year. Well, there's 4 quarters in anything, but we're looking at years. So I'm going to plug into my formula. P equals A is 30,000 over parentheses 1 plus R 0.025 over N, which is 4, to the 4 times T, which is 6. Now, I can type this into Google by typing the following. I will hit 30,000 and then the slash button, parenthesis, another parentheses, double parentheses. Inside this second parentheses, I put this portion in here, 1 plus 0.025 over 4. Then I'll put the caret symbol, another parentheses, caret symbol, parentheses. In here I put the 4 times 6. Close that parentheses. Now I still have the big one from the beginning open, so I'll close that parentheses as well, right? 30,000 backslash, parentheses, parentheses, 1 plus 0.025 slash 4, parentheses, caret, parentheses, 4 times 6, parentheses, parentheses. Typing that into Google will give us our answer. It will give us the answer we want to have. It'll give us the value. And if we type that into Google, give me one moment while I type it just to make sure we wrote the correct thing. 1 plus 0.025 over 4, close parentheses to the parentheses, 4 times 6, parentheses, parentheses, gives me P is equal to 25833.30, and that's dollars, right? He needs to invest $25,833.30 at this time. That should make sense. This is a low interest rate, and it's a low period of time. The longer you leave an investment, the stronger the interest becomes. 6 years is a small time frame to start saving money. He most likely should have started saving maybe 10 years before that. 16 years ago might give him a better savings, right? The longer you invest, the less you have to invest initially, right? The longer period of time. But this is how much William would need to invest. Now, these formulas can be difficult to type in. The important thing is you know how to type them in and you understand compound interest. Now, I've got a bit of good news. This section does not have a homework associated with it. There will be no 10.3 homework. This is the only place this information is going to be given, is in this video, or if somebody brings it up during a live session. I wanted to make sure everyone watched the video in totality before mentioning that. It's important you understand compound interest, right? We just looked at the formula, and we looked at how you could calculate it. These are important to know for financial math, right? If you want to have good consumer awareness, you should be aware of how compound interest works. These things happen when you go to save money. Maybe you go to the bank and they tell you, hey, we can give you this interest rate compounded monthly. But then you go to a different bank and they say they can give you a different interest rate compounded biannually. Well, the formula can tell you which will be a better investment for the time frame you're looking to invest. And these tips and tricks I gave you for typing into Google can help you calculate those. So it's important you understand what compound interest is, but there won't be a homework on this section, since the formulas get a little clunky. There won't be a homework. I wanted to make sure we learned this material, but I'm not going to assess this material in the homework. These questions get a little bit messy, and when we go to take the test, if you don't have a scientific calculator, you can't type this in. If you have a for function, you can't use this. But that is the idea of compound interest. So, make sure you paid attention and learned what we had here. There were some good ideas, but the formulas are a little messy. So just be aware you can use Google to help you understand compound interest. The important thing is you're understanding the idea. And that will be it for section 10.3. I thank you for stopping in, and I will see you next time.